Do you feel the vibes?
So the next step after, what we did last time is trigonometric functions of general angles. So what does that mean? Suppose you have, an angle. Okay? What do you need? Oh, we don't need one. If you have an angle, right? The terminal side, is this blue one here. And suppose it hits or intercepts a point, right? Any random point, 7 comma negative 5, negative 2 comma negative 9, all right? Any random point, or, x comma y, right? Just knowing the coordinates of that point lets you find sine, cosine, tangent of whatever angle this made to get there. Okay? So the coordinate has x and y, all right? You remember what the Pythagorean theorem is, right? X squared plus y squared equals r squared. When you solve that for r, here's what you have, right? So you basically use the Pythagorean theorem to solve for r. R is the radius. It is this distance from the origin to the point. So you use the Pythagorean theorem to find r, and then you can use, sine, cosine, tangent to find, you can use the x and y to find tangent and stuff. So look, sine of theta is always the y over the r, cosine x over the r, tangent y over the x, and so on and so forth. So let's do one. So to find values, if you are given a point, use the Pythagorean theorem, find the hypotenuse r, plug in the values into the formulas, and get the value. Okay, so let's do this one. The terminal side of an angle theta in standard position contains the point negative 3 comma 4. So why don't we just draw that? Negative 3 comma 4. That's that point, right? So I have an angle, right? Basically, it contains that point right there. Okay? Let me make that more straight. Oh, what can I? Okay. Now, we need to find the sine, cosine, tangent of that angle. So why don't we put the angle here? Okay. So now take a look at what you have. I have an x coordinate and I have a y coordinate, correct? This is r. R is always the distance from the origin to the point. So the first step is use the Pythagorean theorem to find the hypotenuse. Okay? So x squared plus y squared is equal to r squared. What is x and y? Well, they're here. They're given to you. So negative 3 squared plus 4 squared is equal to r squared. 9 plus 16 is r squared. 25 is r squared. So how much is r? 5. Okay. So now I have x, y, and r. So just by looking at this, we need to find sine, right? Sine is opposite over hypotenuse, right? What letters would that be? What over what? Y over r, right? And that's the formula right there, y over r. So sine is y over r, which the y coordinate was 4 over 5. Cosine is x over r, and the x coordinate was negative 3 over 5. Tangent is y over x, negative 4 over 3. And now, can we find cosecant, secant, cotangent? We can. They are just the reciprocals. Okay? All right, let's do this next one. Again, I have a point. I need to find the hypotenuse. Now, you can draw this, but I have to say it is not necessary to draw it. Okay, it is not necessary to draw, but you can draw it. Why don't we go ahead and draw it for this one? Here. Okay? So, x is -2, and the y is -1, and theta is here. So now first we need to find r. So x squared plus y squared is equal to r squared. -2 squared plus -1 squared is equal to r squared. And these all become positive, right? Because we're squaring them. 4 plus 1 is r squared. 5 is r squared. R is √5. Okay, so sine y over r, cosine x over r, tangent y over x. So y over r, I just go with my coordinate, right? -1 over √5. But then I have to rationalize. -√5 over 5. Then -2 over √5. -2 √5 over 5. What's y over x? -1 over -2. That's a half. Any questions so far? Now, secant, cosecant, you have to take the reciprocal. But look, let's work smart, not hard. To take the reciprocal, I always go to this step before I rationalize. Because when I flip that, there is no need to rationalize. So this will be just -√5. This will be -√5 over 2. And this will be just 2 over 1. Okay? So drawing is not necessary, but you're free to do it. Okay? Questions? Okay. Let's talk about reference angle. On a scale of 1 to 10, the reference angle, like the importance of the reference angle, is right about a 10. Okay? So let's talk about this. The reference angle is an acute angle. That means it's between 0 and 90. It is formed by the terminal side and the x-axis. But it's got to be the terminal side and the nearest x-axis. The reference angle must always be between 0 and 90 and so on. So let's see how we find the reference angle, right? So suppose you have an angle here of, 50 degrees. Okay? That right there, so the distance between the terminal side and the x-axis, 50. Reference angle is 50. Like there is no reference angle. You know how theta is an angle? Theta with an accent mark is called theta prime. That's usually used for reference angles, right? Instead of using like a whole other letter, you could just, it's like, in Hebrew, like when you have like, don't you have like dots and stuff that make like vowel sounds? Yeah. Yeah, exactly, right? Instead of making like a whole other letter, you could just use like punctuation or accents and stuff, right? Okay, so theta. Why? Right? Theta prime is just 50. There is no such. Okay, so let's take a look at this angle. So suppose the angle here is, 140 degrees. Now, the reference angle is between the terminal side and the nearest x-axis right there. That's the reference angle. So let's try to figure out how much the reference angle is. This is 140. And if it's 180 over the x-axis, then how much is that yellow balance? 180 minus 140, which is 40 degrees. So theta prime is 40 degrees. Okay. Here, this angle, suppose here I have an angle of, 200 degrees. Now the reference angle is between the terminal side and the nearest x-axis right there. So it's 20, right? Because 180 until the x-axis, and then the balance to go more is 20 degrees. So you see how, like, I want you just to reason these out. Okay, so this is, let's say, 300 degrees, right? That's the angle. Theta prime is this. So now, if the full circle is 60, how much is that yellow balance? 60 degrees. So theta prime is 60 degrees. Okay, so let's go ahead and find the reference angle here. We're going to sketch and find the reference angle. All right, so first of all, let me just draw these. Okay, so initial side, 330, we're here. The reference angle is right here, theta prime. So 330 for the blue angle, it's 360 all the way around the circle, right? So Ethan, what do you think about the reference angle here? It'll be 30 degrees, right? 30 degrees. So theta prime is 30 degrees. That's the reference angle. It's that balance right here. Okay. Okay, so next, 250 degrees. Here we go. 90, 180, 250. First thing you want to do is you want to like mark where the reference angle is. In this case, it's this. Okay? So, top part 180. How much more did we go to make it 250? You can use your calculators. Not 110. So it's 180 until here, and then you have to go 70 more to make it 250. Okay? So that's 70 degrees. So it's 180 here, and then 70 here. Total 250. So that's going to be 70 degrees. Okay. So here, negative 120. This time we're going to go in the clockwise direction. So negative 90, negative 120. Now, again, always draw where the reference angle is. It's between the terminal side and the nearest x-axis. That's where it is. That's theta prime. Okay? Yeah. Okay, so if I went 120 here, and the whole thing until here is 180, then this should be 60 degrees. So theta prime is 60 degrees. Okay, now here, let me draw this first. So here is, 360, 40 more. Okay, now, reference angle is this, right there. So I went 360 full circle. And then how much more did I need to go to make it 400 from 360? 40 more. So theta prime is 40. Now, questions? Now, here's an argument to why working with radian is actually easier than degrees. You ready? Because when you have an angle in radian measure, if the radian angle is simplified, so like, 2 pi over 3, right? That's simplified. Then the reference angle is just pi over the denominator. That's it. No math involved. So, if you have an angle, let's say 4 pi over 3, this is reduced, right? The reference angle is just pi over 3. That's it. Just as simple. Now tell me that's not easier than, that degree business we had to deal with. Okay? Huh? Well, it already came to you. It doesn't. Okay. So this is the angle, 4 pi over 3. The reference angle is just pi over the denominator. That's it. Here too. Okay, so now 10 pi over 8, right? 10 pi over 8 technically is not reduced. When you reduce it, this becomes 5 pi over 4. That's reduced. And the reference angle is just pi over 4, right? Okay, so far, the radians have it, 0 to 1 here, okay? Okay, so sketch the angle, then find the reference angle. Okay, so first of all, 35 and 42 can be simplified by 7. You can divide 35, how much is it? Negative 5 pi over 6. So first of all, what's the reference angle here? Just pi over 6. There's literally no math involved here. Now, if we wanted to sketch, this is the initial side. Negative 5 pi over 6, right? So we're going to go this way. So it's 1 pi over 6, and then what's the first one that doesn't cancel? 2, 3, 4, 5 pi over 6. So it'll be here. Okay? So that's how we draw that. Okay. 13 pi over 3, reduced or not reduced? Reduced. So the reference angle is pi over 3. Now let's see how we can draw this one. Okay. So I'm going to let you in on a little secret. Math teachers hate mixed numbers. Okay? Like 1 and 3/4, we hate that. Okay? Like just 7 over 3. 7 over 3. Okay? The one place where I use mixed numbers is when I'm graphing something like this. Okay? So 13 over 3, how much is that? That's 4 1/3 pi, right? Yeah? Okay, why don't we graph this? So here we go. 4 pi, how do we do 4 pi? 2, is that 4 pi? Okay, what else do I have left? 1/3 of a pi. Where is 1/3 of a pi? Right there. So that is how I drew that. Okay? We'll do lots more practice with this. Right now, the most important thing for me is for you to figure out what the reference angles are. Okay. So, find the corresponding reference angle and state the quadrant where it's located. Okay, so let's see. 500. Let's draw this. Oh, okay. So, I go 360. How much more do I need to go? You can use your calculator for that. How much more? 140. So here I'm going to go 140 more. Okay, let's figure. Okay, so first of all, this is in quadrant 2. Yeah? Okay, let's figure out the reference angle, theta prime. So my second time around, I went 140, and I have a balance of 40 to the x-axis, so theta prime is 40. Okay. Negative 2 pi over 3. Quadrant 2. Okay, negative 2 pi over 3. So I start here. I'm going to go 2 pi over 3. So I'm going to go downward. Now, is it going to be in this first quadrant? Here. This is 1 pi over 3. Next up, 2 pi over 3. So what quadrant is it in? 3. And what's the reference angle? Pi over 3. Okay. Now, for the reason why we're doing this, this is it. It's because if you are thrown like any angle at you, right? 11 pi over 6, or I don't know, 15 pi over 4, you should be able to find sine, cosine, tangent of that. And this lets us do that. So take a look. If you have an angle of, like, if you have this angle, okay, sine of this angle is actually the same as the sine of the reference angle. All right? And if the reference angles are just, small, cute little angles. Isn't it easier to find sine, cosine, tangent of pi over 3 than the other bigger angles? So that's where we use them. Okay? All right. Okay, you're staying with me, yeah? Because I feel like I'm going to lose you. Okay, sit up if you need to. Okay, so here's what we need to do. 3-step situation. Find the reference angle, which we now are experts in doing. Next, evaluate the trig function for the reference angle. So for example, oh, is it pi over 3? Okay, I can do sine of pi over 3. Is it pi over 4? I can do sine of pi over 4. Then determine the sign, like SIGN sign. Determine if it's positive or negative. Now for this, we have a mnemonic. Oh, so to do that, there used to be this like mnemonic device, like to help you remember. And it was like, it's always been like the whole world knows it as all students take calculus, but whatever, that's not even a true statement. However, all students take classes. Now that is a true statement. Okay, what do you mean, Miss Malikian? What are you talking about? Okay, so let me tell you. How many quadrants are there? 4. And we go in the counterclockwise direction, correct? So look, here we go. Follow me here. All students take classes. Okay, that's what I remember. Now, these letters all, oh my God, it's also sine, cosine, tangent. So these letters, the S, the T, and the C, they also double for sine, cosine, tangent. A means all, then sine, tangent, cosine. Okay, so what do I mean? Suppose you draw an angle, any random angle, boom, right there. The angle lands in this quadrant, right? In that quadrant, if you have to find the sine of that angle, it will be positive. Anything else will be negative. Okay? So, suppose you have an angle of 200. What quadrant would it be in? 3. If you wanted to find the cosine of that angle, would it be positive or negative? Negative. Which one would be positive? The tangent. Okay? So that's how we're going to do this. Okay, so enough talking. Let's just do one. Cosine of 240. Okay, so first let's draw because I need to find the reference angle. Okay, cosine of 240. Where's 240 these days? Oh, still there, where it's always been. Right there. Yep. Okay. So what's theta prime? So 180, you can use your calculator on this, by the way. 180 until we get here. So we're going to do 240 minus 180, which is how much? 60 degrees. Now, who cares if I need to find the cosine of 240? I'm going to find the cosine of 60 instead. How are we going to find the cosine of 60? We're going to use our cute little special right triangles. Why don't I just draw a, special right triangle right here? 1, √3, and 2. So, what is the cosine of 60 based on that triangle, guys? Cosine of 60. Come on, people who are taking the quiz today. Huh? Cosine of 60. One half. 1/2. Okay. In this quadrant 3, is cosine positive or negative? All students take T for tangent. So it's negative. So the answer is negative 1/2. Because remember, all students take classes, all students take, this is the one with T for tangent. And we're looking for cosine. Okay, so in this quadrant 3, T, tangent is positive. Everything else is negative, so cosine is negative. Okay. Okay? All right. Okay, let's do this one. 5 pi over 6. What's the reference angle? Pi over 6. Okay, so let's see where it lands. We need to know where it lands. So 5 pi over 6. Who says it's in quadrant 1? Who says it's in quadrant 2? Who says it's in quadrant 3? Okay, you can only vote for one.
No,
So
I changed my vote.
it's the second one. You were right. So 1, 2, 3, 4, 5 pi over 6 right here. It's the second one. Now, pi over 6, what's that like? The 30 or the 60? 30. So I need to find the cosecant of 30. Cosecant is like what? Sine or cosine? Sine. So instead of 1 over 2, it would be 2 over 1. So cosecant pi over 6 is 2 over 1. Now let's just figure out if it's positive or negative. 1. In this quadrant, sine is positive, and so is its buddy, the cosecant. So the answer is positive 2. You obviously don't have to write the plus, okay? Okay, 135. 135, right there. How much is theta prime? Use your calculators, figure this out. $45. So I need to find the sine of 45. Okay, that means I need to draw another triangle. How much is the sine of 45? Not with your calculator. Sine of 45. Opposite over hypotenuse. How much is it? 1 over root 2. Which is root 2 over 2. Okay, in this quadrant, is sine positive or negative? Positive. So it's root 2 over 2. Okay. All right. 7 pi over 3. What's the reference angle? Okay, now we need to draw this. Oh boy, okay. All right, guys, watch me here, okay? In this quadrant, we have 1 pi over 3. Next one is 2 pi over 3 because it doesn't cancel. 4 pi over 3. 5 pi over 3. I need to go more. 6, 7 pi over 3. Now I'm back here, okay? Okay. So I need to find the cotangent of pi over 3. What's cotangent? Okay, so go over here. Cotangent of pi over 3. Are we looking for the 30 or the 60? 60. Okay, so find me the cotangent of 60. Okay, but what over what? So cotangent is adjacent over opposite, 1 over root 3, which is root 3 over 3. Okay? All right. In this quadrant, everything is positive, right? So it's just root 3 over 3. Okay, 2 more. What's the reference angle? Pi over 4. So now I need to find the tangent of pi over 4. Okay, let's draw this angle, see what quadrant it's in. Now, I'm going to do a little survey. So figure out where it is. I'm going to ask you which quadrant it's in. All right, so who says it's in quadrant 1? The 5 pi over 4. Who's 5 pi over 4? Who says it's in quadrant 2? 3, 4. Okay. 1, 3, 5 pi over 4. It's here. Okay. So Tangent of pi over 4, how much is it? How much is it? How much is it? Tangent, tangent, tangent. 1. In this quadrant, is tangent positive or negative? Positive. So the answer is positive 1. Positive. That's tangent's quadrant. All students take classes. Okay. 2 pi over 3. Let's see where it is. Who says, okay, so go ahead and draw it. And then I'll ask you what quadrant you think it's in. Ready? Who says quadrant 1? Who says quadrant 2? Who says quadrant 3? You have to vote. How about quadrant 4? So 1 pi over 3, 2 pi over 3 is in quadrant 2. Huh? Remember, it's like a clock. 1 pi over 3, then the next coefficient that doesn't reduce with 3 is the 2. So 2 pi over 3. Huh? What? Yeah, so the 3. 2 doesn't simplify with the 3, so it's the second one. Okay, what's the reference angle? Pi over 3. So I'm looking for the cosine of pi over 3. Pi over 3 is 60, so I go over here. Adjacent to hypotenuse of 60 is 1/2. 1/2. Okay, positive or negative there? Negative. So negative 1/2. Okay, so this is how you do it. Moral of the story. Draw yourself, a pair of triangles, and you're going to refer to that every single time. Soka, yeah, always. SOHCAHTOA you have to take with you everywhere you go, right? And basically this lesson is putting together everything we've done so far. So everything we've done is building up to this. This is why I do things in such a specific way. Okay.
Press start.